Today we shift gears, and rather than talking about triangles, we're going to talk about angle measurements. What we've been used to looking at are degree measures. And today we're going to discuss a new type of angle measurement called a radian measure. And what a radian measure is it's the angle's measurement relative to its distance, or arc length if you want to call it that, around a circle. So if I had an angle that looks like this, rather than using a protractor to say that that's 30 degrees, we talk about how far we've traveled around the circle to describe that angle's measurement rather than that degree measurement of the opening. So we're going to need to talk about circumference, which is 2 pi r. And if it's a unit circle or a circle of radius 1, then we know our circumference is 2 pi. So we're going to develop some radian measures for a unit circle in an intuitive way. If we start at 0 degrees, which is in our standard position, and go all the way around the circle, which we know normally is 360 degrees, in terms of radians, then as we just discussed, that circumference of the circle is 2 pi. If we were to go halfway around, then that's half of 2 pi. So 180 degrees is equal to pi. If we were to go a quarter of the way around, that's half of a half, or pi over 2. And if we were to start splitting this up into relative equal parts, and we were to say, okay, well, let's cut this half circle, which represents pi, into 6 equal pieces, then those 6 equal pieces would be a sixth of pi. So I could say this angle right here is pi over 6, which we know if I take a sixth of pi, or a sixth of 180, a sixth of 180 is 30 degrees. So pi over 6 is equivalent to 30 degrees. If I take another sixth, that's 2/6 pi, or pi over 3. And if I take 2/6 of 180, I know that's 60 degrees. If I take 3/6 of pi, then that's half of 180, or 90 degrees, which is pi over 2. I could go ahead and again intuitively state, well, if I were to take a fourth of pi, then this would be pi over 4, and a fourth of 180 would be the same as 45 degrees. I can continue to do this all the way around and develop my 30, 60, and 45 degree specialty angles all the way around the circle in an intuitive process. And if I did so, then I would end up again with a unit circle that we've seen before, but now we're going to throw in our relative radian measures. So 30 degrees, there it is. It's pi over 6, 45, pi over 4, 60, pi over 3. If I go another 60 degrees, then that puts me at 120, or 2 pi over 3 in radians, so on and so forth. So now what we're going to have to do is we're going to have to know our radian measures relative to our degree measures in a unit circle, as well as their corresponding x and y values. Now we're going to use this information to answer a couple of questions. First of all, for non-30, 60, 45, 90 degree angles, we're going to take and use a conversion ratio to change from degrees to radians and radians to degrees. And that ratio is the radian measure over pi is equal to the degree measure over 180 degrees. So if I was asked to take and convert 70 degrees to a radian measure, I take degrees, 70, over 180, and set that equal to my radian measure over pi. Well, 70 over 180 goes to 7 over 18 equals my radian over pi. Therefore, my radian value is equal to 7 pi over 18. Likewise, I can do the same with 248 degrees. I can say 248 over 180 is equal to my radians over my pi. And simplifying this just basically results in reducing this fraction. And in reducing that, I get 62 pi over 45 is my radian value. Now we're going to take and convert to degrees given radian values. So I know my degrees over 180 is equal to my radian value, which I have 5 pi over 8 over pi. Well, the pi's will reduce in this case, which means my degree equals 180 times 5/8. Doing the multiplication, I get 112.5. Similarly, doing one more problem, I get degrees over 180 is equal to 11 pi over 4 over pi. So the degrees is equal to 180 times 11 over 4, resulting in 495 degrees. Let's move forward. So without a calculator, what we're going to do is we're going to evaluate the following. We're going to find the cosine of 2 pi over 3. And as we did before with degrees, we need to answer 3 questions. Where are we? What are our x and y values there, and which values do I need? So 2 pi over 3 is in the second quadrant. And I know 2 pi over 3 have x and y values equivalent to that of 120 degrees. So those x and y values are -1/2 and √3 over 2. But I'm looking for my cosine value, which means I need my x value. Therefore, -1/2 is equivalent to the cosine of 2 pi over 3. When asked to find the sine of 11 pi over 6 in the negative fashion, I know 11 pi over 6 is just short of 12 pi over 6, so I'm right here. This is equivalent to really the same as pi over 6 if I look at its coterminal angle. And I know my x and y values at pi over 6 are √3 over 2 and 1/2. I'm looking for my sine value, which means I need my y. And my y in this case is 1/2. Moving on, I need the tangent of 5 pi over 3. Again, where am I? Sorry. 5 pi over 3 is 1 pi over 3 short of 6 pi over 3, so that puts me somewhere over here. I know that I have x and y values of 1/2 and -√3 over 2. And my tangent is my y over x value. Therefore, I have -√3 over 2 over 1/2, which simplifies to -√3. Now, in this next example, it's a little more difficult. I'm looking for the secant of -22 pi over 3. I need to find out where that is. Well, the way I like doing it is I like saying, well, -22 pi over 3 is equivalent to -7 1/3 pi. Well, let's take a look at a circle and find out where we are. -7 pi, where is that? Well, negative direction means I'm spinning in a clockwise fashion. This is 1 pi, 2 pi's, 3, 4 pi, 5 pi, 6 pi, 7 pi puts me right here, and I have to go 1 more pi over 3. So I'm ending up roughly here. This is the same value as where 2 pi over 3 would be. And I know the xy values there are -½ and positive root 3 over 2. I need secant, which is 1 over the x value. And 1 over the x value in this case is 1 over -½ which gives me -2. Let's keep moving. We're going to find the cosecant of 47 pi over 4. Again, we're going to take and convert this to, let's see, 11 3/4 pi. So again, where am I? If this is 0, 1, 2, 3, and you'll notice the pattern here, everything on the right is an even multiple of pi, everything on the left is an odd multiple of pi, and I'm going this time in a counterclockwise fashion. So 11 pi puts me on this axis, and then I need to go 3 pi over 4 more, which puts me in the 4th quadrant. Having the same reference angle as 7 pi over 4, my x and y values in that quadrant for 7 pi over 4 would be root 2 over 2 and negative root 2 over 2. And I'm asked to find the cosecant, which is 1 over my y value. My y value is negative root 2 over 2. Multiply by the reciprocal, and I get negative 2 over root 2, but I'm going to have to rationalize that. So this gets me negative 2 root 2 over 2, or negative root 2. Couple more. We're going to find a positive and negative coterminal angle for the following degrees. Now, if you remember, coterminal angles are angles that have the same terminal ray. And in order to do that with degrees, we needed to either add or subtract 360 in order to get a coterminal angle. So at 5 pi over 3, I am in the 4th quadrant. To get a positive coterminal angle between that, I would actually have to take and add 2 pi. Now 2 pi added to 5 pi over 3 is the same as saying 5 pi over 3 plus 6 pi over 3, which gives me 11 pi over 3. Now, the problem with this is, even though it's coterminal, it's not between 2 pi and negative 2 pi. So, in essence, I really can't find a positive coterminal angle for this first guy. I could probably find a negative, but not a positive. So in this case, if I want to find a positive coterminal angle for 3 pi over 7 of the negative type, I'm going to have to add 2 pi to that. Adding 2 pi is the same as adding 14 over 7. And in this case, I'll get 11 pi over 7 as a positive angle that is still less than 2 pi because it's less than 14 pi over 7. So this actually checked out. This I wasn't able to do. But I did show you the process in which you'd use to find it. Next example, we need to know where the following lie. We want to know what 1 radian is equivalent to. We know pi radians is on the negative x-axis, if you will, over here. So what is pi equivalent to? It's 3.14. So 1 radian would be actually less than half of a pi. And we know if pi is here, half of a pi is the positive y-axis. So then half of 3.14 is about 1.7-ish. So then 1 radian would have to be somewhere in the first quadrant. So if I want to know where 4.5 radians are, then I'd have to find out where in this whole circular process is 4.5 relative to pi and relative to 2 pi. So I know that pi is 3.14. I know 2 pi is double that, so 6.28. If I take and find the midpoint of those two, then I should be able to find where 4.5 radians is. So it turns out that this axis here gives me 4.7 radians. So therefore 4.5 radians is somewhere down here in the third quadrant. Now, these next two ideas, you're pretty much going to have to memorize the formula because they're all formula driven. If we want to find the arc length, which is known as S, of some circle, that means we're finding out, well, what is the length of this exterior part of the circle? Well, you have to multiply the radius times the angle, but the angle's got to be in radians. If we wanted to find a sector area, that would mean like taking a piece of pi out of the circle and finding its area. And that's equal to a half the radius squared times theta. And again, theta's got to be in radians to do this. So let's say we're given a central angle of 80 degrees. Here's a circle, roughly 80 degrees, let's say, is somewhere right around here. And we want to find the arc length and the sector area of that. We know this is 80 degrees. Then it's basically plugging and chugging into the two formulas. So first of all, we're going to need to find the radian measure of 80 degrees. So I take 80 over 180 is equal to the radian measure over pi. So the radian is equivalent to, let's see, 4 goes into that, 2 pi over 9. And therefore, my arc length, S, is equal to the radius, which is 5, times 2 pi over 9, which you could find a decimal equivalent for if you'd like. And then the area is equal to a half times the radius squared times the angle, once again, 2 pi over 9. Pretty much just plug and chug into a formula. The important thing today is being able to identify all our 30, 60, 45 degree angles with their equivalent radian values, and then being able to find the sines, cosines, tangents, etc. with them. So here are your questions to answer for the day, and we will go through some more practice tomorrow.